Hello everyone! In this tutorial, I'm gonna show you how to set up and run a linear static simulation on a clamp arm. A clamp arm is a component of a bench vise mechanism, and as you can see in this picture right here, it is responsible for securing the vise to the working bench. This part experiences significant forces during tightening. That's why we need to ensure that it holds up under pressure. Let's start by creating a new study. Click on Simulation, then New Study. Static is selected by default, so just click on OK. Now, the first step is applying the material. Typically, the clamp arm is made of cast iron or steel, depending on the design and application. Here we're gonna choose steel. Right-click on clamp arm, then select Apply Material to All Body. I'm gonna choose stainless steel ASI 304. Just type 304. Select it. Click on Apply, then Close. Alright, now that the material is applied to our part, we need to fix it. Right-click on Fixtures, select Fixed Geometry, and let's select this face and this face. Now click on OK. If you go back to take a look at the whole mechanism, you will see that this is where the screw is meant to be. That's why it's fixed. Alright, now we need to simulate the forces coming from the workbench or whatever surface we're fixing the vise on. Because as we all know, Newton's third law says that for every action there is an equal and opposite reaction. So our action here is the force that we applied by tightening the clamp, and the reaction is the force that the bench pushes back with. To simulate this force, right-click on External Loads and select Force. Now, let's select the contact surfaces between the clamp and the working bench. And let's set our force to 300 Newton. Now click on OK. Now our next step is to mesh our part. Right-click on Mesh, select Create Mesh, and click on this little arrow to expand the mesh parameters. For this study, we're going to choose a standard mesh with a global size of 3 mm and a tolerance of 0.15. Click on OK. Now that our part is fully meshed, we can run our study. Click on Simulation and run this study. And here is our result that we can animate by clicking on Stress. Right-click on Stress, select Animate, and here we go. Watching the animation can be really useful to help you verify that the fixtures and loads are applied correctly. If the part deforms differently than expected, you might need to go back and double-check the fixtures and loads to make sure they are applied correctly. This part is deforming as expected, so we're good. In the result plot, we can see that the unit is megapascal with 3 decimal places, while the questions require that the maximum stress is in megapascal with 5 decimal places. To adjust this, we can right-click on Stress, select Chart Options. Now scroll down a bit and set this value to 5. If you need to change the unit, you can click on Definition, and here you can select the desired unit. I'm gonna leave it megapascals as it says in the instructions, and I'm gonna click on OK. And here is our maximum stress in megapascals with 5 decimal places. The same principle applies to the second question. Double-click on displacement to activate it, then right-click on it and select Edit Definition. Here we're gonna change the unit to inches, and let's change the decimal precision by clicking on chart options, scroll down a bit, and make sure the value here is 3. Now click on OK. And there we go. Here we can see the maximum displacement in inches with 3 decimal places. Now let's go back to the stress plot to interpret our results further. On the right, you can see a color-coded plot showing the maximum and minimum stress using the von Mises criteria. And a common misconception for new simulation users is that red is bad and blue is good. Well, that can be correct in certain tests, but the color code simply represents the maximum and minimum stress that the part is experiencing under the applied load. To interpret the results in a meaningful way, you must pay attention to the value in the legend. Notice at the bottom of the plot, you can see the yield strength of the material. In this case, the maximum stress is higher than the yield strength of the material, which means that the part will experience permanent deformation or even failure under the applied load. So the current design is not strong enough for the given load. And that wraps up this tutorial. If you found it helpful, don't forget to like, comment, and subscribe. See you in the next one.